Now we are going to discuss illustration number 20. In illustration number 20 we have been provided two resistors, one with R1 and R2. The current flowing them is I1 and I2. If the joule heat produced in them is minimum, at that time we have to find out the values of I1 and I2. But as shown in the figure, we can say that I is equals to I1 plus I2, so I2 is going to be I minus I1. And if we are accepting that the joule heat produced in the first resistance is H1 and the joule heat produced in the second resistance is H2, according to equation we can say that H is equals to I square R only. So H is equals to I1 square R1 plus I2 square I2. But we know from this equation that I2 is equals to I minus I1. So we can say that H will be equal to I1 square R1 plus I minus I1 square R2 only. Now, but for the minimum heat, we have to accept this thing that dH upon dI1, that is going to be 0. That means the differentiation of heat with respect to one of the current is going to be 0. That is the condition for the minimum heat joule dissipated. So we are just putting out the values. H is equals to I1 square R1 plus I minus I1 whole square R2. The same equation has been followed here, and then we are separating this term. So it is reduced to d by di1 of I1 square R1 plus d by di1 of I minus I1 whole square R2, that is equals to 0. But here from this term R1 is constant, and from this term R2 is common. So R1 d by di1 of I1 square plus R2 d by di1 of I minus I1 square only. Now we are going to differentiate that equation.